This is a temperature measurement system software for Jonathan Griffiths in LabVIEW. The program sits inside a while loop, which is refreshed every 10 milliseconds. First of all, two analog inputs are fed to myRIO, one from the voltage supply, and second from the potential difference in voltage from the thermistor. These are used to calculate the changes in resistance. This is done by subtracting the potential difference in voltage from the voltage supply, and then this difference is divided by the voltage supply to be given as a percentage. This is multiplied by the nominal resistance of the resistor of the thermistor to give us a change in R. This is fed into the Steinhart art and beta formula calculations to be converted to temperatures. We also require constants. These are pre-calculated from the information supplied by the thermistor datasheets. The conversion from resistance to temperature is given in Kelvin. These are displayed on the front panels. The user requires the temperatures in Celsius, so to convert these from Kelvin, we just minus the figures by 273.15. This is connected by the thermometer, which you can now see on the front panel, which ranges from 0 to 100 degrees Celsius. Celsius is converted into 5 SI units in temperature. Firstly, in Fahrenheit, by multiplying the Celsius by 1.8 and then adding 32, get the Fahrenheit. By adding the Celsius by 273.15 and then multiplying by 1.8, we get the temperature in Rankine. By subtracting the Celsius by 100 and multiplying by 1.5, we get the temperature in Dalsile. And finally, by multiplying Celsius by 0.33, temperature is given in newtons, and these are all collected and displayed on the front panel. The temperature measurement system also indicates to the user predetermined cold, ambient and hot temperatures. On the software, the predetermined cold is given as less than or equal to 20. When this figure is hit, the output is inverted and sent to pin 15 to allow current to flow and light the cold LED. The ambient temperature is predetermined by being less than 30 but over 20 degrees Celsius, and this inverted signal is sent to pin 13 to allow the ambient LED to light. And finally, hot temperature is determined by being greater or the same as 30 degrees, and this inverted signal is sent to pin 11.